Remember when looking at the box plot, the width of the box is the distance from Q1 to Q3, and that is a measure of spread called the IQR. So let's get into that a little bit more. The IQR is the interquartile range. Inter meaning between, so between quartiles. It's the range of the middle 50% of your observations or of your data set. So let me scroll back to the graph real quick. Remember that each section has 25%. So the box would be 25 on the left, 25 on the right, which makes 50% of your data. So the middle 50% of your scores have to fall in there. So the bulk of your students or the bulk of your scores or the bulk of your whatever are falling between Q1 and Q3. Now, this is another and often better measure of variability of a data set than standard deviation. And that's because standard deviation is not resistant to outliers. Standard deviation gets yanked around because standard deviation was the deviation from the mean, and the mean was not resistant. Thinking back to our tarantula example way back in section 3.1. The IQR, on the other hand, is resistant. It resists outliers. So the width of the box in a box plot is the IQR. Right? It's Q3 take away Q1. It's resistant to outliers, which makes it very nice for skewed data, which is exactly where we're going with this. Now, this picture should look familiar. We actually already had this table, but at the time we didn't have quite a sense of what everything was. So now we've got it a little bit better. When you have a skewed left data set, and this is what that looks like, your mean would be significantly less than your median. Now, how significant is significant enough? Well, that's kind of a judgment call you have to make. So, but you kind of look at a graph or look at a box plot or look at, some other features and kind of gauge it. There actually is a measurement for it, but we're not covering it in a Stats 1 class. It's called a skewness factor. But for our purposes, just kind of look at the graph, look at the dot plot, look at the histogram, look at whatever. Right? The median then would be the better measure of center because it's resistant to the skewing. And if you use the median, then you use its companion, which is the IQR, because they go together in the 5-number summary. Remember, the median is the center, and the IQR is the interior spread. Let me scroll back up here in the 5-number summary. Right? So, and the box plot gives them to you because the box plot gives you the center line, which is the median. That's this blue one at Q2. And then it gives you the spread, the interior spread of the data, which is the width of the box from Q1 to Q3. Okay, so similarly, if it's skewed right, that would mean the mean is significantly greater than the median, in which case you'd want to use the median again because the median is resistant to that skewing, and so is the IQR. So they go together. The median and the IQR go together like peas and carrots, right? So if you have the median here as your better measure of center, then you have the IQR to go with it as your better measure of spread. Now, a lot of what we do kind of once chapter 7 hits, to be honest, is work with symmetric data. Symmetric data is when the mean and the median are basically the same, approximately. So you would use either x bar or mu, which is the mean. And when you're thinking to yourself, well, which one? The answer is it depends. Are you talking about a sample? If you're talking about a sample of data, then you'd use x bar. Are you talking about a population? We'd use mu. We tend to use mu more often once, I don't know, chapters 5, 6, 7 hit. Then we tend to use mu more. In chapter 3, we tend to use x bar more. And then in chapter 9 and 10 and 11, we actually compare the two, right, and figure out how they change. Similarly, if you use x bar, meaning you have a sample, then that means your standard deviation would be s, as in sample standard deviation. And if you use mu, then you'd use sigma because sigma is the population standard deviation. So which one to use just depends on your data set. For future reference, this book and the projects and the worksheets will often ask you to describe a distribution. When they put that in there, they say describe this distribution. What they really want to know is what's the shape, what's the center, and what's the spread. Shape meaning symmetric, skewed left, skewed right, right? Uniform is another one, etc., right? But those three are the big ones for us. The center, well, mean or median. Because if it's symmetric, then you're better off with the mean, right? and then you're better off with the standard deviation as your measure of spread. So those go together. If it's skewed, then you're better off with the median because the median resists that skewing. And so does the IQR. IQR, the interquartile range from Q1 to Q3, is also resistant to skewing because they're basically mini medians. Q1, remember, was the median of the bottom half, right? And Q3 was the median of the top half. Since they're both medians on their own right, they're also resistant to skewing. So IQR, which is the distance between them, is resistant, and therefore it's a better measurement to use when your data set is skewed. Okay, let's recap a lot of this for our example problem. Same data we were working with before. These are it's a sample of exam 3 scores. Okay. Well, the range, let's start with the range. Range is really easy to find because range is max minus min. So all you have to do is look for your highest value and your lowest value, which is really easy because I put this data set in order. So it's 93 take away 54. Now, if I didn't put the data set in order, it wouldn't matter because your calculator finds the max right there at 93 and the min 54. The calculator doesn't find the range, but it'll find the pieces for the range. Similarly, the calculator doesn't find the IQR either, but it does find Q3 and Q1. You can see them right there in the one variable stats output. So the IQR is Q3 minus Q1, which would be 88.5, take away 76, which is 12.5. Now the mean is the mean, right? Now ask yourself, is it X bar or is it mu? Well, this was a sample, right? And since it was a sample, that means that we're really talking about X bar. So X bar is 80.897, approximately. So I'm going to put little squiggly equals with that one. Right? It says it right there at the top of the calculator. And now the median, I got to scroll back down for that one. The median was 84. And we can just use capital M for it if we want. There we have that. Standard deviation, everybody's favorite. Standard deviation was, let me see here, S. So we want S because we want X bar. This was, it's right there, 10.598 roughly when we approximate. So 10.598. And then last but not least, the variance. Now, just a little refresher. The computer doesn't find variance. The calculator. Computer would find variance, but the calculator won't. So how do we find it? Well, the calculator found standard deviation, and the variance is just the standard deviation squared, remember? So take your standard deviation and square it. All right. Well, we have calculators to do this for us, so we will just have it do it. And when we do, we would take S, which is 10.598, and square it. And you get 112.32. If I do the variables number 5 statistics, number 3 SX, and square it, it'll be a little bit more accurate in terms of decimal places, so that's 112.32. Honestly, I don't mind either one you want to use. It's fine with me. But there you have it. So now let's describe the distribution of this data set. Okay, well that means they want shape, center, and spread. And they probably don't want them in green. All right, so shape, center, spread. What are they? Well, let's think. Shape would be skewed left, skewed right, or symmetric. So the shape would be, look at your mean and your median. It's a little bit skewed left, right? Because your mean is significantly less than your median. I mean, your mean's kind of on the low end of a 3.0, and the median's like right hovering on 3.0 to 3.5 range. So it's a little bit skewed left because the mean is less than the median. All right, now what about the center? Well, if it's skewed, then you're better off with the median, right? That's what the table above says, right? So the median, if it's skewed left, then we're better off with the median because the median is resistant to that skewing. So we're going to use the median, which is 84. And actually, I should have been more clear. The data points, or the units for this problem, sorry, the units for this problem are points. And so all of these values, I put points on them, points on them. To be fair, I should have done it back here a couple pages ago. So these were actually points as well. All of these values, other than the variance, which is weird, but the rest of them all have points as their unit. So PTS, 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 right? Points. Sorry. So the 5-number summary has the same units as your data set. So do all these other statistics. The only weird one is variance, which is points squared. Sorry, I forgot to mention that before. So the variance is a little weird because it's points squared, but the rest of them all are points. The 5-number summary is all points, so are all of these values. Okay, so that's when I say the center, I should say the median was 84 points. Now it's just points because this particular problem was an exam. I mean, if it was inches, then you'd say inches, or I don't know, degrees Celsius, you'd say degrees Celsius. You use whatever unit your data set has. Now, as for the spread, well, you have choices. You can use either the IQR or the standard deviation. In this case, we're going to use, you guessed it, the IQR, and that's because the IQR is resistant to the skewing, right? So we use median and we use IQR because they're both resistant. So IQR, interquartile range, is 12.5 points. And remember that we use, you can make a little note, we use median and IQR because they are resistant to the skewing of the data set that we said was there in the first part for the shape. And this leads us to our last little bit of information with regards to the IQR, which is that we use the IQR and the quartiles as well in order to officially check for outliers. So to check for outliers is a 4-step process. You find your Q1 and Q3, which are found, quite frankly, with your calculator, or I mean, you could, if it's easy enough, you could find it by hand. And then you find your IQR. Now, to be fair, for this problem, we've already done those steps. We've already found Q1 and Q3. You can make a little note. You find with one variable stats on the calculator if you're using a TI-84. All right, now you have to find your fences. So to find your fences, you're going to use the 2 formulas given above. Now remember, for your exam, you don't have to memorize those formulas. You just have to be able to use them. All right, so the lower fence would be Q1 minus 1.5 IQR. Let me type that up. All right, I got these numbers as my fences, but let me prove it to you. So 76 take away 1.5 times 12.5. Now the thing to do is to type that all at once in one line in your calculator, because the order of operations says that the calculator should actually multiply the 1.5 times the 12.5. So please excuse my dear Aunt Sally, multiplication comes before subtraction. And then on the other side, 88.5 plus 1.5 times 12.5, 12.5, close parentheses, enter, and you get 107.25. So those are your fences, right? Anything in between those numbers, not an outlier, right? Anything outside of those numbers, outlier. There, I just put that in there to remind you. So, and including those fences, by the way, but the fences themselves do not have to be part of the data set. You're just saying, hey, this is the normal zone, right? Anything in here is fine, but anything out of here is an outlier, weirdo, and we want to make a note of it. So if we look at our data set, we actually have 2 numbers that are outliers, and it's 54 and 56. They're below the lower fence of 57. We don't have any outliers on the high side because we had no values that were above 107. Matter of fact, 93 was our highest value. So there we have it, 54 and 56, both of them are our outliers. oops, I can spell, because they are lower than the lower fence, which often I abbreviate to LF just for my own sanity's sake. There are no outliers on the high side because if there were, the maximum would have been higher than that upper fence, and the maximum was not higher than the upper fence. The maximum was only 93, and 93 is not above 107.25. So there you go. Now you know how to officially find outliers using the lower fence and the upper fence and how to create those fences. Don't forget that this whole process here could get put right on your note sheet for your exam.